Thank you for coming tonight, and thank you for your interest in the topics of which the brethren have chosen. And I've given them a number of topics of which I feel comfortable in sharing. And tonight, to their recommendation, we're going to talk a little bit about the theory of evolution. And it doesn't take long to give consideration as to what the impact of evolution is in our society. It is certainly taught and in the school systems. It is certainly promoted in television series and various forms of publications, television, radio. Everywhere you look, you will see some form of evolution being put out into our society and really kind of assumed to be already factual. Now, it's called a theory, and theory means that it is ideological, meaning that it has some idea of which there is some support of evidence. Now, for those of you that don't know me, I actually have a geology degree. Before I became a geologist, I actually started out seeking to be a biochemist. And so I've looked at various parts of science, and through the years of studying science and learning about evolution, which is really taught as a foundational element to almost any science that you study, through the years I've had to weigh and consider the facts that are being stated or being taught in the school system, and then also even beyond that into my career, as to give consideration as whether or not I find it to be factual, or do I find it to even have enough supporting evidence to really believe in it. And tonight what I want to share with you is why I as a scientist really struggle to believe that evolution is the answer to where life began. Now, of course, a Christian believes in the biblical story. And in Genesis chapter 1, verse 26 and verse 27, we find that God ultimately makes the statement and then declares that He has created man in His image. And the idea there, the idea of creation, comes from a Latin word, ex nihilo, meaning He created him from nothing. So God has miraculous creative power, and He is all-powerful, and He has power beyond really how we can fathom in the physical sense. But we read about it in the Scriptures, and if you believe the biblical account, then that is the story you believe in. But that's not what's taught today in society. And what's taught today in society are things pertaining to this theory called evolution, which ultimately supports the idea that man is a byproduct of happen chance, and that ultimately we were created by accident, and that life began this way and ultimately evolved to the point that we are today. So I'll teach you some of those principles. I want to teach you those things particularly so that you can appreciate how, as a scientist, I want to walk you through my test to determine whether or not evolution really stands up to the measure of science. Whether or not you really can test it to find it factual, or if it is failing in a number of areas. So I'm going to begin by giving you, first of all, a couple of definitions and also a couple of main principles about evolution so that you can appreciate what we're going to have to test and then see what the evidence states about it. So evolution, first of all, is not simply a matter of change over time. Now, when you think of evolution, you might think that way, but that is not the way I want you to think about evolution tonight. If that was the way that evolution really is, then we could propose that this would be evolution. It is a change over time, but this is a destructive change, and this is a deterioration of things, and this is how things work in the natural systems. Things typically degrade from some particular higher element, from some state of ultimately being at a, for instance, in the case of radioactive decay, you may start with a parent element, and then ultimately through decay over time, that material will decay away and ultimately be transposed into something else over the time period. And so in this case, this would be change over time, but it's not an evolving type of change. Instead, evolution is defined as a gradual process in which something is transformed into a different and usually more complex and superior form, meaning it actually improves over time versus degrades over time. What do I mean by that? Well, if we were going to use our Volkswagen as an example, then what I'm saying is evolution looks more like this. It looks like the product of what engineers do and how things are improved upon and how they continue to be created in a sense that they're getting better through time. And so already we can see that there's a fundamental problem in this idea of evolution, because naturally things don't typically do this. But that's what the theory proposes. So what we want to specifically talk about is what we hear of in the news as evolution, what's called Darwinian evolution. It's really called biological evolution. It is the process by which different kinds of living organisms are thought to have developed and diversified from earlier forms during the history of the earth. And that history of the earth ultimately has evolved over a period of billions of years, and we'll talk about that here in just a moment. And so it really is, as Time magazine shows right here, how supposedly we became human, evolving from lower life forms to the point that we are today, and that we are just a stage in which things will continue to evolve into the future, such as many of your science fiction movies and cartoons and things of that nature ultimately try to propose and fantasize about, and how things will continue to become more evolved through time. Well, there are certain principles of evolution. There's 5 main ones, and I've kind of subdivided the first one here, even though they can stand alone. The idea, first of all, of abiogenesis or biogenesis. They are distinctly different because of the A meaning not at the beginning of the word, bio meaning life, and genesis, how it began. So abiogenesis, to begin with, is simply defined as the original evolution of life or living organisms from inorganic or inanimate substances. So this is how life got its start, supposedly. And the reason it's called not biogenesis, life beginning, means that it is how life began from non-life. Because in the beginning, supposedly, there wouldn't have been life, but somehow life had to get a start. So what we're taught in the textbooks and in the classrooms is that supposedly in the early primordial earth, while things were starting to kind of turn down from a violent nature of Earth's beginning, which would have started out as some molten magma ball, that ultimately through degassing of various gases and elements, and through electrostatic electricity and just the right mixture of things on the ground, that suddenly lightning would strike a mud puddle, creating some spontaneous reaction, and then ultimately life would come forth. Life would be sparked. So lightning striking a mud puddle starts life, according to the textbooks. And unfortunately, young people gobble this up, and they believe it to be true, because who would question a teacher? Who would question the professor in the classroom? Who would question the textbook, which supposedly is representation of the facts? Well, overall, this is called spontaneous generation, how life suddenly just popped up and began. And already I have a problem with it, because why doesn't it continue to be the case, and why did it only happen once? If we have billions of years to work with, we shouldn't just have one chain of life, which we'll see here in just a minute. There should be multiple competing chains trying to out-compete the other to ultimately be the higher level organism or levels of organism that are ultimately coming into creation. But we don't see that, and it's certainly not taught in the classrooms today. Well, supposedly, in 1953, a student by the name of Miller with his professor Urey ultimately did an experiment in their laboratory as Miller was working on his master's degree. And in that particular situation, Miller proposed with his professor that they could recreate this early life in a laboratory and ultimately make this spontaneous generation of life in the laboratory and ultimately prove this to be true. So what they did is they took this particular apparatus, and I won't go into all the details, but here's what I want you to understand. What they did is they took the gases and the chemicals they needed to engineer organic materials, and then they created this entire experiment and test based on their own creative ability and knowledge of understanding, applying all of those things, and then they sparked it, and what did they get? They got what they believe were simple basic building blocks, amino acids, proteins, things of that nature, or the beginnings of proteins, to ultimately create what they would call life. Now, they didn't create life. In fact, they were far from it. In fact, there's even problems with the product of the things in which they made, which would be attacking of life, like ammonia, which ultimately acts as an acid when it reacts in this kind of chamber and breaks things down and destroys. But ultimately they proposed that they actually created life in this case. Well, they've never created life. And in fact, since 1953, no one's gotten anywhere close. Still, no one has ever created life in a laboratory. The day they create life in a laboratory and something walks out on its own, I'm going to give them a thumbs up and say, you know what, now you maybe got something. But they've never gotten close. Never gotten close. So there's already a problem here. And abiogenesis, the ability to create life from non-life, has never happened, not even with the greatest minds of all of our world. And all of the education and availability of all the power out there. Still, no life has ever been created in a laboratory. Well, let me give you the definition of biogenesis. And biogenesis is a step forward from life from non-life. This is actually life evolving from other lives. And so this is how the whole evolutionary process gets started and gets going, is it is the production of new and different living organisms from other living organisms. And this is called, as Darwin entitled it, evolution of the species. And supposedly, it looks something like this, from single-cell organisms ultimately evolving through aquatic life, ultimately to life on land, and then making its way to the human being at the top of the chain. As I like to propose, it's from the goo to you by way of the zoo. That's one way to think of it. That's a little crude, but this is proposed, again, in the classrooms as being the key to how we understand evolution. These are the facts that are taught to our young people today. So we now move from the beginnings of life, and now we're going to need 4 other principles to ultimately make evolution work, is what is taught by the biology professors. First of all, we're going to need what's called random mutation. And random mutation has its advantages, and we certainly need it. For evolution to work, random mutations, which are a sudden departure from the parent type in one or more heritable characteristic caused by a molecular change in a gene or chromosome. This is called genetic modification. So, quick example. Here's a nice little calico kitty for the kids. Not very many kids here, but the few that are here, hopefully they can appreciate it. What's the problem with the calico cat? The calico cat has a blue eye. And calico cats don't always have blue eyes. Some do, some don't. But in this particular genus, this cat should actually have the gold eye, which you see on the left. The blue eye is an anomaly. It is a genetic mutation because it's wrongly coded. So occasionally you need one of these. Now the real question is this an advantageous alteration? Now, if suddenly this eye allowed this cat to see in total darkness or to see the mouse behind the wall, now suddenly we have a mutation that actually could help the cat. And somehow that would have to be transmitted down through the progeny or into its children to ultimately be an advantage and the speciation to start to occur. So that gives you yet another principle. There's also what's called natural selection. And natural selection is the process whereby organisms better adapted to their environment genetically tend to survive and produce more offspring. Darwin called this survival of the fittest. So you have to have the ability for certain genuses to outcompete others to create a shift in the population, which ultimately is an advantage to a particular species rising above those of other competing species. In the cases typically shown in natural selection is the case of this particular moth. Now you see the white moth on the dark bark, and the problem for this particular moth is that it's going to be visible to, let's say, a bird. And a bird which eats moths as a food product is ultimately going to pick off the white moth on the dark bark. So white moths are not going to have an advantage over, let's say, the dark moth down here below, and hopefully you saw that. So here's the darker colored moth of the same genus, and this moth would have an advantage because of its darker texture. The darker texture should be one that ultimately allows it to outsurvive the lighter texture. Now here's the problem with that. How many of you seen other trees of different colors, such as colors of whites and grays, where this particular moth would have an advantage over the darker one? And if it's such an advantage, why are white moths still around today versus those of the darker ones? If natural selection worked the way it is proposed, then ultimately certain species should have died out and should not even be around today. And so we'll examine that for a little bit. Transitional forms. Now transitional forms are important also. These are called missing links. The definition of transitional forms is fossils or organisms that show the intermediate states between an ancestral form and that of its derived descendants. And one that comes to mind typically is what's called Archaeopteryx. And Archaeopteryx is on display at the Oklahoma Natural History Museum in Norman, Oklahoma. It's just a copy, and those copies are all throughout the world in almost every natural history museum. Why? Because supposedly it's the link between dinosaurs and then ultimately the species aves, birds. And so it is proposed as supposedly this divergence away from its ancestor to ultimately create a new species. So speciation through evolution supposedly occurring. And we'll talk about the human one here in just a minute. Then finally, the fifth principle of which all of this has to be run by is you have to have enough time for this process to work. So you have to have geologic time. According to the geologic, when I talk about geologic time, I'm talking about a really long period of time. We're talking about currently today 4.65 billion years. And what's interesting about geologic time is it itself has evolved, because as scientists have needed more time, they just add on more time. And so when I first started out as a youngster in school, and some of you that are older, you'll probably remember, the number used to be much smaller. Well, the number has grown because of the need for more time as more species have been found and more rock layers are discovered. Therefore, they just keep adding to the number. Today it's 4.65. Who knows what it'll be? It's already starting to round up and is probably getting closer to 4.68 depending on who you talk to. So the key is all of the geologic rock record supposedly represents, through all of the fossils that are found within it, this 4.65 billion years. And it's a big number, and it's hard to get your head around it, but that won't be the talk tonight. But we're going to talk about these 5 principles. So we have the ideas of biogenesis, random mutation, natural selection, transitional forms, and geologic time. Now, to set up our test tonight, we're going to set up a hypothesis using the scientific method. And when we do this, what we have to do is we have to propose an idea. The hypothesis is that evolution is true. That's our hypothesis. Evolution is the process by which life began. Now, it's taught as such, so let's put it to the test. So, then we're going to set up a procedure and an experiment. We're going to look to see are these things supported, and has science fully supported all of these principles so that evolution can stand as a functional theory. Then we're going to look at the data, we're going to look at the results, and then we're ultimately going to come up with our own findings and conclusion here this evening. I know it sounds like a lot. It is a lot, so we're going to move quickly. Most of this is taught in about a semester. You're going to learn it all in the next hour. So it's a lot to think about, and the great thing is it's being recorded so you can come back and revisit it. So let's begin our test. First of all, abiogenesis. As we stated, it's never been done in a laboratory. If you can't start the process, it's hard to believe the process even works. But here's what we're going to do. We're going to discount that this evening. We're going to test the other 5 things, and we're not going to worry about that, even though it is a major failure for this particular theory. So let me give you the evolution stories as taught in the classroom, and we're going to come down to a low level so that you can grasp some of the basics, because this is what your kids are being exposed to in the classroom in science. So this is out of a new textbook published just in the last 2 years. It's called Evolution. And this is just the animal kingdom represented. Here's the student studying biology, wishing to know all about their origin. And so what do? They show this family tree of how first life ultimately evolves into all of these different things. And of course, it will propose that the mammals and reptilians are closely related to the human. But on down the line, starfish, worms, jellyfish, mollusks, sponge, even protozoans are all our relatives. We're all related. So man's not so unique after all, according to the biologic evolution theory. Man is just a thing that evolved over time from these other things. And then supposedly other things will come along afterwards. Well, that's a very simple version of what ultimately is a huge database of all the different species. And this is a very simplified format. But what supposedly this is representing is Earth's beginning all the way back here at 4.65 billion years, and then stepping out at 500 million year intervals is how evolution begins to fan out into all of these various species and forms. And what we have is man way over here on the end. So you start here and you follow the tree and you can see all the bacteria continue. Then you get into eukaryotes, protozoans, you get into the protistas, you ultimately come around here to fish, amphibians, reptiles, birds, mammals, and then way at the end is human beings. Now you do have some extinction events. Here's dinosaurs dying out back at 65 million years ago. And then here's some others, and we're going to talk about these here a little bit this evening. We're going to save dinosaurs for tomorrow. But ultimately, we're going to talk about everything pretty much from over here in pink all the way around. We're going to cover all of that here this evening. But I want to start with just humans way over here on the end and talk about its closest relatives. The humans are closely related, and most closely related, according to evolutionists, to chimpanzees. Then obviously you get all the way down through the apes, then into the monkeys, and then to the prosimians. And all the way at the end, our distant relative is called the lemur. And a few years ago, there was an IMAX special out. It was called Meet the Lemurs. And it was cute, it was colorful, it was musically inclined, it was for kids of all ages to go see. And what was it about? Cute little animals? No, it was learning about your relative. That was the sole purpose of that IMAX special, was to teach you and to embed within you an understanding of evolution, and to do it so subtly as to you to buy into that idea because of all the cute little characteristics the lemur shows that are so human-like, or at least that they mimic to be human-like. Well, the point here is that supposedly this tree, going all the way back to 65 million years ago, according to this idea, is that after whatever killed off the dinosaurs, whether it be a comet or meteor impact, whether it be global cooling, global heating, degassing of the core, who knows what it was. They can't seem to come to some kind of agreement on that. But the point is that after that event, then we had this whole evolutionary chain occurring. Now, what's interesting about this is that back here, this connection back to the monkeys and towards the humans and apes is the last common ancestor of monkeys and apes lived about 25 million years ago. Now notice here, there's a representation, but there's not a picture. Why is that? Because they theorize it occurred, and there is nothing factual to support it. We're going to talk about that and show some proof of that here in just a moment. The problem is, it's a missing link, but they don't have it. It's still missing. It's still missing. So then we move forward, and then what we have up here between chimpanzees and human beings is another one. The last common ancestor of humans and chimpanzees lived between 8 and 6 million years ago. We do not have its remains. So we're talking about a theory that's being taught as fact, and what's the problem? They don't even have any evidence. They don't have all of the pieces of the puzzle to tell you how it works. It's like saying that the light bulb will turn on and that a generator can produce electricity, and they don't have any wires in between them. They don't have the connections to show you how it works. So it already has some fundamental problems. But let's go ahead and let's focus on these last two. Let's just look at our closest relative, supposedly, the chimpanzee. Let's see what the evidence has to say about that. Well, here is a breakdown of our closest relative, the chimpanzee, and supposedly there's been these other hominids, other human-like beings that you've heard about, such as, and we are obviously Homo sapien, but there's the Neanderthal, there's Homo erectus, there's a number of others here, and of course, if you look at the beginnings of the term, you'll see kind of what region they come from, whether they're Asian or they come from Australia. But these supposed hominids were found and ultimately are tied to our relative, the chimpanzee. Now here's the part that's kind of difficult to understand, is that supposedly these are all of our linkages, and yet none of them exist today. None of them exist today. Only us and the chimpanzee. Everything else is missing. Everything else is missing. They are simply found in the rock record. They are discovered by archaeologists and paleontologists. That's how they're found and discovered today. But there is none living that we can ultimately examine, study, let alone do some kind of DNA evidence or DNA mapping to see how closely they're related to us. So how do they determine this? Well, ultimately it comes from either fossils or bones. Fossils and bones is ultimately what they look at to try to figure out some of these connections. So here is these connections with the actual evidence. These are the things actually used to make these determinations. Now, to help us understand if this makes sense or not, I'm going to put down here at the bottom right an actual modern human skull. So we can see the human skull. And even though you're not paleontologists, and even though you're not necessarily biologists, I'm going to give you a really basic understanding of what you look for. What do you look for? Notice the ovate shape, roundness to the skull. Notice the rounded eye sockets. Usually the nose is missing because it's cartilage, so it doesn't usually survive. Notice how the eye is ovate and ocular. It sticks out for the eyeball to fit into this socket. Notice there's a recession here for where the eardrum is. And then you also see the facial feature coming down very narrowly to the forefront of the teeth area, and then there's ultimately this kind of tight jaw that's associated. Now, many of these obviously don't have a jaw. Some of them do. But we can see right away Homo erectus, the Neanderthal, things of that nature. They look very human-like, don't they? You can see that from this particular picture. Now, let me look here and notice that even though these are distinctly human all the way back here, that there's actually some up here at the top that don't look very human. In fact, you can tell because in the cheek area, it's extremely flared. It's a very large upper mouth area. It has a very small skull area, and it also has this kind of this winnow peak, kind of like my hairdo, winnow peak. But it's got this change in its skull feature that's very different. It's very distinct. And when we go and we look at modern skulls that are available to look at, we find this one, what's called a pan-troglodyte, that looks much like it. You see the big eye area, you see the winnow peak on the skull area, you see the wider upper mouth region, and you can see the flares at the cheekbones. And if we take away the lower jaw, it looks just like these all across here on the top. But what's a pan-troglodyte? Well, pan-troglodyte's a chimpanzee. Chimpanzee. So what do we have? Well, we have distinctly chimp, we have distinctly human, and then we have this guy back here that supposedly is the connection for them all. And notice everything in black is assumed, only the white is the true bone that is found in the fossil record. And the problem is that little bit shows a flared cheek area and a wide mouth ridge and the bigger teeth of the way that they're formed. And notice it removes the winnow peak and changes the skull feature a little bit. Why? Because they want to artistically represent something that might connect the two. There is no data there. So what's the problem? It looks like a pan-troglodyte. It looks like a chimpanzee. So it's really not a link. It's really not a link. So this begs the question, is this real? Especially when you go way back here and look, only a couple of bone fragments supposedly to find all of the ancient ancestors. And that's what you'll find. The farther we go back in time, the less you've got to work with. So artistic representation starts to really come in. So let's play, according to the Boston Science Museum, a game called the Skull Game. And we're going to look at these skulls of supposedly our ancient ancestors. And in the hominid skull game, it says, can you identify early human skulls and discover what they tell us about human evolution? And what happens is, kids are walking by, it's down low, it's easy for them to get close to see, to touch, to feel, to play with the buttons. And what is it doing? It's teaching them about evolution. It's teaching them about evolution, and it's trying to impress upon them that this is an evolutionary process going on here. But what do you now know? You're now enabled to determine what is distinctly human and what are chimpanzees or pan-troglodytes because of the features that are distinctly different from the humans. Are they related? No, they're a different animal. And they're truly, in this case, an animal. It's a chimpanzee. So, The humans, they certainly stand out. Are they related? Is there some kind of variability in human beings? Did we have ancient ancestors that passed away and ultimately have fallen into the rock record and are extinct? Well, let's just test this idea for a second. How can we get variability? Well, what we're taught is that variability in these particular skulls, as I also put the skin texture on, the color, the size of the face and the shape of the lips and all of these things, they ultimately try to paint a picture that this is an evolutionary process by which something ultimately evolved into a human being. Now the variability, if you look very close at the facial features, you will see that yes, there are differences of shapes and styles based on the skull that's underneath all this, but then you got to remember a lot of this is actually added on to give you this pictorial. But how do we get variability? Do we see variability in nature? Here's a species, canines. And how much variability is in one species of animal called canine? A lot. A lot. And due to various breeding, obviously you get a lot of different features, sizes, different shapes associated with just this one species that still has the ability to interbreed. So variability is possible. But let's make that test even more interesting. How about with human beings? Can we have that kind of variability amongst human beings? Can we have all of those skull shapes that are truly hominid or human, and it makes sense in the modern world today? I propose to you it can. I propose that all you got to do is go out there and look on the internet. You can see enlarged skull cavities. You can see elongated jaw features. You can see things that are of all different shapes and sizes, and yet they are all human. All of them are human. And it doesn't matter if they look Neanderthalic with a raised eyebrow, or a blunt forehead, or an elongated face. It's still human. And yes, those skulls are going to look different. And so underneath this skin texture, from this artistic impression, is people trying to give you the idea that they're different species, but that isn't the case. They certainly fall within the normal parameter of variability of human beings today. And so what do we know? They're human. They're ancient humans whose remains we found. And that's it. And that's it. Even though they try to paint a majestic story to give you this idea of evolution. And so when it comes to these principles of evolution, we have to have these random mutations, and we have to have natural selection trying to ultimately alienate certain species to rise above others. And then we have to have enough geologic time, and if enough of that is working together, we get to this thing called transitional forms. We get to those next links or missing links. And then if you have transitional forms, and if you have enough geologic time, you get to this idea of biogenesis of new species ultimately evolving from others. And if you have biogenesis and enough geologic time, you ultimately get the process of evolution. That's how it's proposed. Does that actually work? Well, as I said, abiogenesis doesn't work. You can't even get the process started. But when it comes down to our theory, we have to understand that yes, when it comes to these ideas, let me back up, can we have random mutations? Can we have natural selection? Well, let's see if the next process works. Genetic mutations. Wouldn't it be nice if you could have more than just 5 fingers? How many of you are like me and sometimes things just slip out of your hand? Wouldn't it be nice to have a couple extra fingers and just really grab onto something? Well, genetic mutation, there is enough DNA code and there is enough randomness out there that yeah, you can have an extra finger. But you know what? You can have a whole lot of toes. And how many of you ever thought, man, I wish I had an extra arm or hand? Well, yeah, you can get that too, and you can have a third arm. Yeah, mutation takes place today, even amongst the human species. But does it evolve into something that ultimately carries this on from generation to generation? Do we have people with 3 arms or 4 arms out there today? The answer is no. The answer is no. So ultimately, we understand that DNA can get miscoded. And when it gets miscoded, you can have mutations. But here's what we need to understand. Is it biological evolution to have a miscode? Well, what do we know about it? Genetic miscoding most often results in birth defects, tumors, or cancer cells, leading to death if untreated. It's a life stopper, not a life starter. And then, in very limited cases, altered genes can be transferred to progeny or children, but the trait is typically recessive, meaning it usually doesn't come through. It usually doesn't come through. And so just because a person has an extra finger or extra toes or an extra arm, even if they can reproduce, the chances of the child actually having that miscode is nearly impossible. Because what DNA typically does is when it bad code latches onto what is yet another good code from a parent, it'll typically correct itself and kick out the bad code and goes back to the original form. So you don't get mutation leading to speciation. It doesn't occur that way. Let me give you proof of that. There have been numerous genetic experiments trying to prove that the evolutionary process works. And man has tried to play God in the laboratory, trying to ultimately take one species and turn it into another species. And one of the species they've done the most experimentation on is this particular species called Drosophila. And Drosophila is nothing more than the fruit fly. You ever seen one up close? You're always batting at him, right? This is what he is. There's the Drosophila. Here's a fruit fly up to, there you see the scale, just a couple of millimeters across. Well, what do we know about Drosophila? Why do we experiment on Drosophila? Well, we experiment on Drosophila because it can go from egg to adult and able to reproduce in 10 days. So its cycle to ultimately create new life, very rapid. 10 days, very rapid. You can have 36 generations in a year. So we can have those 35 to 36 generations in a year. That means 1,000 generations every 25 years, 20,000 years for humans to reach 1,000 generations. So it's advantageous to experiment on that which can regenerate the most rapidly. So a lot of experimentation has been done. It's 800 times faster than humans. So it synthesizes time. So we can't create time, but we can synthesize it through narrowing our scope of our study to that of a species that gets recreated quickly. But here's the other thing. Don't we want to create as many as possible? Well, the Drosophila works well for us. It lays about 100 eggs a day. It lays about 2,000 eggs in its lifetime. So therefore you get the maximum population and variability. So you're making as many as possible, as fast as possible. So if you can then impose upon it, instead of natural selection and unnatural selection where you're forcing the genetic coding to do things that are unnatural, you should be able to create a new species if it's that easy. If evolution is going to work by accident, surely the scientists and engineers can make it work in the laboratory over the course of the last 100 years of which they've been experimenting on it. But what do we find? After all the experimentation and all the variability that has ever come out of Drosophila, seeing all the different body sizes and the different colors and spectrums, seeing even the eye color variation within particular species, and even seeing that you can create additional abdomen areas as well as extra wings, different legs. Yeah, man's learned how to manipulate the genetic code, and he's done a really good job at being able to predict what it's going to do when he changes the genetic mapping. But see, most genetic miscodes, though, end up in death. So you only get things that look like Drosophila. And never have they ever made anything that's different than Drosophila. Yeah, some weird variations, but it's still a fruit fly. Now here's what the BBC recorded in June of 2004. The headline was, "Scientists see new species born." Well, that headline says, "We've seen evolution in the laboratory." So what do we find? They said, according to their particular post, the BBC, British Broadcast Centre, says whether the two closely related fruit fly populations represent one species or two is still debated by biologists. So what happens is they've created what they think are a deviation from the species to where they no longer reproduce amongst each other, therefore a new species by definition, no longer able to reproduce. However, university researchers believe the insects are in the early stages of diverging into separate species. In fruit flies, there are several examples of mutant genes that prevent different species from breeding, but scientists do not know if they are the cause or just the consequence of speciation. So these scientists want to get out in front and they want to say, hey, we are the first ones to actually see the biologic evolutionary process in a laboratory, and we're here to declare it to the world. You know what I get from this article? It's still under debate by biologists. They are ultimately saying they believe by faith in this idea, and they really just don't know. That's what they said. That's what they said when you read between the lines. At the end of the day, 12 years later, do we really have the new species of Drosophila? Do we have the research to back it up? Has it been published? No, this went away into the quiet, just like many scientific experiments that ultimately don't lead to anything. They didn't have it. They never created a new species of Drosophila. They just created one that couldn't breed. So now, in the closing minutes that we have here this evening, we have a lot of fossils found out there in the rock record. Now we're into my world. We're into geology. And paleontology is a study of ancient life based on the fossils that are found out there in the rock record. And I see fossils all the time, found fossils, certainly have a collection of fossils at the house, and enjoy looking at fossils and enjoy studying them. Because it is an interesting look at something that's not around here anymore. And it's curious as to what life must have been like when it was around, such as dinosaurs. But the fossil record should show clearly, without a doubt, that if the evolutionary process works, which we are seeing has huge problems, can't be recreated in the laboratory, then surely over the millions and billions of years, the fossil record should show clear evidence of the evolutionary process taking place and saying, wait, there could be some credibility here to this whole theory after all. Well, let me show you what the fossil record shows, and let me show you from a different perspective you're not going to see in a textbook, and you're certainly not going to see in any kind of publication, TV program, let alone some movie that has the word Jurassic in it. They're not going to teach you this. So what's the fossil record look like? This is the fossil record condensed into a particular plot here. Supposedly, this is 4.5 billion years ago. Here's current, here's the present. Life began supposedly back here at around 4 billion years old as taught in the classrooms today. So what I want to look at is just this period of the last 550 million years. And the reason I want to focus on that is this is starting with what's called the Cambrian explosion. So when you see that fan of that life I showed earlier and it just explodes all over the place, this is the time period where all of that begins. So life starts to really evolve. Evolution kicks into high gear, and evolution is taking place rapidly. So we should see evolution all throughout the fossil record to ultimately prove this theory. So there's a couple of iconic fossils, and I'll show you where they fall on the scale. In the 230 million to 65 million year time frame, the Mesozoic, which is the Triassic, Jurassic, and Cretaceous, is the dinosaurs. And supposedly they went extinct 65 million years ago with some catastrophic event. But then there's also this little guy called a trilobite, and there's all kinds of forms of trilobites. They're cute little things. You can find lots of them here in Oklahoma. This goes back to this entire period back here called the Paleozoic, which is 520 million years ago to 240 million years ago. Now both of these are extinct, so we can't really look at them and use them as something today, but we do have things alive today that went extinct, and we can get an idea of how long have they been around, or how long did they occur in the geologic time before they supposedly evolved, or if they evolved at all. So let's look at a few. Here's a sand dollar. Sand dollar is an echinoderm. This is what it looks like modernly. I'm sure none of you have one that looks like this, because we only find its skeleton, which looks like this. But they're cute, they're fuzzy. This is how they look like when they're alive. So here's a sand dollar. Notice there are certain ports. There is certain shape to the skeletal feature. It looks like starfish. There's a reason why. They are echinoderms, they're related. But here's a fossil of one. Here's a fossil of one. Again, you can see some of the conduits. You can see the same similar shapes. This one supposedly is 20 million years old. And you notice the shape and the star cluster looks just like this modern one here on the left. Now they come in different shapes, but these two are exactly the same. They're exactly the same. Now here's the problem. That sand dollar hasn't changed in 20 million years. 20 million years. Now, how many of you, and this is just a question to ask yourself, don't raise your hand, don't respond, but how many of you have had children? And how many have children that look exactly like you? Not many. Maybe some that represent or have a certain likeness to you. But if you think about generations of human beings, or even generations of dogs, or generations of Drosophila, there's always going to be variability. But this sand dollar looks really close to that living one there today. And in 20 million years, it supposedly has failed to change. It has failed to evolve. Okay, now maybe 20 million years isn't enough, and maybe this isn't a complex enough species to see mutation and to see a change in the evolutionary process. So let's look at some others. How about a bat? Bats are kind of unique. In fact, there is nothing like the bat. We refer to them as flying rodents. They're kind of an interesting animal. It's a true mammal, but it flies. It has nocturnal abilities. It has a really unique sonar. It is a very curious and very unique species and has very special characteristics. Well, here's a fossil of a bat. And here's what it looks like, very much like its skeleton. But what's interesting is this one's 50 million years old and still looks like a bat. 50 million years, and this so unique a species that you would think is a higher end of an evolutionary process has not changed in 50 million years. How about some others? How about a horse buried, also notice uniquely, with fish? Curious. I don't think horses spend a lot of time swimming in lakes and oceans, but this one obviously spent time with them because that's where he was buried. 50 million years old, looks just like a horse. How about a turtle? 50 million years old, and this turtle looks uniquely like this particular one here on the left. It looks like the same species. 50 million years and no change. How about insects? Now these are really curious because these are very specialized. And in fact, there's nothing like the dragonfly out there. It's a beautiful creature. Then there's a bumblebee. And yet we can find these in the rock record. Here's a dragonfly. Here's a bumblebee. Looks just like their modern counterparts. The problem is they're 70 million years old, and these small creatures have never changed. Here's the problem. 70 million years old for these two rocks predates the cataclysmic event that ended the lives of the dinosaurs, and yet no speciation or mutation through that process. Whatever ended all of life, or a majority of life on Earth, had no effect on some of the smallest and most unique and sensitive creatures in all the world, one of which needs pollen to survive. And yet supposedly a cataclysmic event on life didn't end its life. Amazing. Here's a frog, an amphibian. Here's a couple of fossils, look just like its modern counterpart. It too is 70 million years old, so it was had its beginnings when the dinosaurs were still alive. Here's clams. Clams, obviously we enjoy them to eat, but they also can be found as shells or even in the rock record. This one here's 80 million years old. Kind of seeing the problem here, right? We're going older and older, and nothing has changed over time. Evolution is failing in all of these cases. And you notice we're also looking at all sorts of kinds of animals, and now we're getting into some really unique ones. Here's what's called a needlefish. It's a chordata. And as you can see here, by its beak, by the placement of its fins, very unique animal, and yet there it was, alive and well, 100 million years ago, according to the rock record. We're literally giving the geologist and the evolutionist their time frame. And we're showing you how it works against them, right? Even if you give them the time, they don't see evolution taking place, which makes you wonder if the time is right or if evolution ever occurred. How about this one? Here's one of the oldest mammals known today. You can see actually remnants of its fur by radioactive decay in the rock. You can see its skeleton. Its skeleton matches. This is actually the drawing of supposedly what this animal looked like. And as you can see, there's an animal today called a tree shrew. It's a mammal that looks just like it. This one was 125 million years old and was running around at the feet of the dinosaurs. A mammal, no change. Here's what's called a narrow claw crawfish. It's a crustacean. You can see that it has an interesting facial whisker system, which here it's kind of pulled in tight, but it can fan out. It has its antennae. It has these narrower pincer claws. And then it has, obviously, a certain amount of appendages on the side. And it's got a fanned, kind of a platy tail. And you can see, look just alike. 150 million years, we're back to the Jurassic now. We're into the Jurassic time period. How about this one? This is a very unique type of shark called a squatina, called the angel shark. And as you can see, it looks nothing like a modern shark. It looks more like a stingray. But as you can see, it's got multiple fans for large fins on its body. It's got the elongated tail with unique set of fins on it as well. Has a very unique placement for its eye socket up on top of the head. This one, very unique, but yet 150 million years, no change. 150 million years, no change. Evolution is failing the test. A couple more. Here's one called coelacanth. Coelacanth is another chordata. As you can see here it is in the rock record, the fossil record. Here's a couple of modern shots, and there's scuba divers as proof. 155 million years old, going back to the Jurassic. Now here's the problem with coelacanth. Coelacanth was once touted as a missing link in the evolutionary process. Here's what they say about coelacanth. Coelacanth disappeared from the fossil record with the last of the dinosaurs that was supposedly 65 million years ago. Of course, its beginning is about 155. In the early 1900s, evolutionists touted it as the first walking fish, meaning the one thing that came walking out of the ocean, made its way onto land, and that's where all the mammals came from. He says the transition between fish and tetrapods, that means animals, that is until 1938 when one was found alive and unable to walk. Coelacanth blew up in their face. What did they do? Dismissed it, moved on, and they just changed the story. As I always say, the only thing really evolving in the evolutionary theory is the evolutionary theory. It's failing. It's truly failing. How about a salamander? I'm going to move quickly here. 160 million years old, according to these particular fossils and rocks. And there it is in comparison to a modern skull and vertebrates. And you can see they look just alike. Here's a very unique reptile called a gavial. The gavial here has a very small, slender beak with a big nose, but the rest of it looks just a lot alike to the crocodile or the alligator. And what's interesting about it is, it supposedly had its start around the Jurassic period, time of the dinosaurs, but here's what they say about it. It says the order Crocodilia consists of 23 species, crocodiles, alligators, caimans, and gavial. Crocodiles first appeared nearly 160 million years ago and have changed very little since. This is their own admission. What did they say? These species, and you can look at alligators and crocodiles and caimans, and you can see them also through the fossil record and through time, and just like this very unique species, they're not evolving. They're not evolving. Here's a horseshoe crab. And I remember seeing this in my paleontology book when I was back in school. And I thought to myself, what a weird and ugly animal this thing is. It's kind of scary looking, really. What I didn't know is that actually they're still alive today. And that really began to make me question things. I tried to balance the idea of evolution in an ancient earth with a Christian belief of creation. And I played with that idea for a while, and it really challenged my faith. But you know, when I saw this thing, literally a dead one washed up on a South Carolina beach, realizing how old this supposedly is and is none changed, I started to have doubt on the whole evolutionary process. Because in this particular case, this one's 160 million years old from the Jurassic. But this guy right here is 445 million years old. We're going all the way back to nearly the beginning of the Cambrian life explosion, and this guy never evolved. Never evolved. And what I haven't shown you is not only was there a period here where there was extinctions, there are multiple extinction periods all the way through the geologic time scale, yet this guy survived them all and never even changed. That's a problem for evolution. Here's the brittle star. We looked at a sand dollar a moment ago. The brittle star is an echinoderm also. It's a starfish. You can see it has a unique body. It's got cilia along its legs. We can also see here that it's got a unique center. Almost looks like a star, not starfish, the sand dollar. But it is very unique, and guess what? Here it is in the rock record, found next to these guys we talked about earlier that are extinct, called trilobites. And trilobites, we already know, not only in this case 150 million years old, but this one here has got to go back here, and sure enough, it's 450 million years old. 450 million years old, and all these extinct critters that are supposedly the beginning of life, actually we're finding this animal was with and never changed. Never changed. Then here's a starfish, and you can kind of guess where we're going. 40 million years old for that one up there at the top, but 450 million years for this one here at the bottom. So here we are. We looked at this tonight. And what I want you to take away from this is that after this Cambrian explosion, which occurred right here, and you see just a few life sources all of a sudden explode in this entire tree, this entire fan of evolutionary process and speciation. We've looked at tonight representation. First of all, let me tell you, that's skewed. That's 4 billion all the way to 550 million. So that is 6 times larger than this time frame here. So all of it has been very recent, supposedly. They do this to help you digest this idea. But the point is, we've looked at all of these examples tonight. All of these examples, all the way around the evolutionary tree and fan here. I like to say fan because it looks more like a fan. But the point is all of these species have failed to evolve. And when you have failure across this large a representation of life on Earth today, all kinds of species, all kinds of phylogeny, then evolution is not living up to what teachers are trying to express to our young people. What they're trying to sell you is something that they can't prove, but they teach it as if it's fact. And the problem here, what we've seen tonight is it's not meeting the expectation of even the scientific method. And as a scientist, I have a huge problem with this because I know how to test things. You yourselves know how to test things, but we're not being told enough fact to realize that this one doesn't pass a test. And it means we need to question it. And we need to help our young people to see the lies that are told and to help them to see things like this. So, tonight, can we have random mutations? Sure, we can have it. Can we have natural selection? Yes. But did we get to transitional forms? No. Do we have enough geologic time? Well, we question all of the geologic time just based on the fossils not changing over time, because if that's been that much time, things should have changed. And so we question that without even having to go into radiometric decay or radiometric dating and all those things. So at the end of the day, we don't have biogenesis and we don't have evolution. So here's a couple of quotes to close with tonight. Charles Darwin himself in 1859 in his Origin of the Species made this statement, realizing what the one problem with his theory could be in anticipation that ultimately it would overcome it, but never did. He said the number of intermediate varieties, meaning missing links, which have formerly existed on Earth must be truly enormous. Why then is not every geologic formation and every stratum full of such intermediate links? Geology assuredly does not reveal any such finely graduated organic chain, and this perhaps is the most obvious and gravest objection which can be argued against my theory. This was 1859. And today, in 2016, the story isn't any better. They still don't have the missing links, even though a few have been touted. Stephen Gould is a professor who passed away some years ago, but he was the leading professor of the Geology and Paleontology department at Harvard University. He even said this. He said, the absence of fossil evidence for intermediary stages between major transitions in organic design Indeed, our inability, even in our imagination, to construct functional intermediates in many cases has been a persistent and nagging problem for gradualistic accounts of evolution. Later, he would promote something called punctual or punctuated equilibrium, meaning it happens so fast we just are never going to see the intermediate transitionary forms. The missing links just aren't going to appear in the rock records. There's not enough rock to capture it. But here's the problem that he didn't address. We looked at the species over geologic time and we didn't see them change. And that in and of itself is a problem because there's no missing links in those cases because there never was a transition or evolution process in place. It failed and never met the expectations of what these professors promoted. So tonight in close, I have a problem with evolution. I don't think it meets any expectations that I would have as a scientist or anything that I would ultimately want it to prove. And because of that, I have to look for what's called an alternative theory. I have to say, okay, evolution's over here. It doesn't meet my expectations. It doesn't pass the tests. So what are my alternatives? And you know, today in our world, with all the creative minds, there's only one other alternative that's embraced by the world today. And that's Genesis chapter 1, verses 26 and 27. That man was created in the image of God. And that God created him. Created him, just as he did all living things, the world, the universe. There is a power out there, a designer, that has the ability to make whatever he wants, and we are the product of his. And if this other theory is false and this theory is true, then you know we're accountable to the designer. We're accountable to our Creator. And being accountable to the Creator means someday, according to his book and according to his word, which we're going to continue to examine through this weekend, that if all of those things are true, then what that story ultimately tells me is a day of accountability is coming when I'm going to have to answer to him, and that he has set certain expectations in my life, and if I haven't met them, I'm going to be punished. And if I have met them, I'm going to face blessings that I can't even begin to comprehend in this earthly temple.